Okay, so I just wanted to do this last example on the next video, and it refers to Noone's law of cooling. You will need a calculator for this, and so just kind of reading through this, it says, okay, so the rate of change in temperature of a hot cup of coffee is proportional to the difference between its own temperature and the temperature of the surrounding air. Okay, so again, we have a differential equation, right? The difference between the rate of change, and it's telling us that F would be our temperature at any point. So, like for Fahrenheit. So let's go ahead and say, okay, so we have dF dt, little t, is proportional to the difference of the temperature, and then it's the surrounding air. And it says the surrounding air is 68 degrees Fahrenheit. Okay, so this becomes our differential equation that we're going to need to solve. And it gives us two data points. And let me clean this up just a bit. So I want to go ahead and solve this, and then plug in the two data points and then answer the questions. So F minus 68 needs to get to the left, and the dt needs to get to the right. So it would be 1 over F minus 68 dF is equal to K and then dt. And again, we want to integrate both sides. And so my hope is that after 3 or 4 examples, you start to see the structure and the way that these will be solved. The antiderivative of this is natural log, and it doesn't need a chain rule because the coefficient of F is just 1. So go ahead and put an absolute value. Here's our famous antiderivative, kt plus c. And then let's go ahead and e to the from both sides. So e to the, e and ln cancel. So we get F minus 68 is equal to, remember that's a big constant that we'll put in front, e to the kt. Add the 68 over, and so now we have a function of temperature, c e to the kt plus 68. Now, the initial time, right? The coffee is brewed at a temperature of 180 degrees. So that would be how hot it is at t equals 0. And then here's our second data point. At t equals 5, it's 165. So t equals 0, we know it's 180 degrees. So now I can at least put that in my data point, that 180 is equal to c e to the 0 plus 68. So subtract the 68 over, we should get 112 equals c. So now I just have one more data point to go. So F is equal to 112 e to the kt plus 68. And then I remember in 5 minutes, I think it cooled 5 degrees, right? So it's 165 degrees. So 165 is equal to 112 e to the 5k, should be a k, plus 68. Okay, so when we subtract the 68, we're going to get negative 97 is equal to 112. Oh, sorry, not negative 197. Wow, how embarrassing. 97. There you go. 112e to the 5k. Now, we'll go ahead and divide over this 112 and then end up taking the natural log of 97 over 112. That'll give us 5k. And then we want to take 1/5 of that. So 1/5 natural log of 97 over 112. Now that obviously not a clean answer. So what I'm going to do is I'm actually going to store that. So I'm just going to type this in right now, just so I have that stored in my calculator. Divided by 112, natural log, and then divide by 5. So the a few decimals you should have is negative 0.028. And there's like a 7575786. It keeps going, equals k. So I don't want to have to remember all those, nor do I want to have to write them all down. So I'm going to store that. I'm going to store my calculator as some coefficient, like maybe a. That way I can recall it each and every time. So store as a, which is awesome. Okay, so now when it asks us write and solve a differential equation that describes this situation, so one way that you can write this, so we knew that it was F equals 112 e to the kt plus 68. And now I've seen this on the AP exam where it's, it kind of gets messy to put a long decimal in the exponent. So I leave it as a k. And then they say where k is equal to, and then they give well more than 3 decimals of accuracy. Negative 0.02875. And as long as you give at least, I would say 4 or 5 decimals, you'll be fine. So like that way it looks a little cleaner. Okay, then B, it says, what temperature will the coffee be after 16 minutes? So that is, I think, the easier of the two, because we can just evaluate F of 16. And, wherever that 16 is for T, we solve. So let's go ahead and do 112 times E raised to the K. Now remember, I stored that in my calculator as an A, times 16 plus 68. So you should always give things to 3 decimals of accuracy. So 138.695 degrees Fahrenheit. And then one thing I should say too, maybe you noticed this, but I think it's worth mentioning, K is negative. So that means we're decreasing as an exponent, right? Like a negative exponent means you're decreasing over time, which is perfect because you want your temperature of the coffee to cool. So, it gets closer and closer to the surrounding medium, which is the right, which is room temperature. And then part C, now we have to solve this. This is how long will it take it to reach 120? So this is a little bit tougher to do. 120, then just simply plugging it in. 120 equals 112 e to the kt plus 68. So now we need to solve for t. We already know what k was. So we can subtract our 68 and then divide by 112. And then do the natural log of both sides. So right now, I have about negative 0.76725, it keeps going forever, equals k, which I've stored, times t. So I'm going to divide that k value to the other side, or the a value, which is stored in my calculator, divided by a. And so I'm getting time to be 26.68. I guess go one more decimal, 0 minutes. Okay. And every once in a while you'll see a Newton's law of cooling problem. I know in pre-calc you do them. You do Newton's law of cooling, but they give you the formula. Here we just basically derived it, right? Because it's going to be proportional to what its current temperature is and that of the surrounding area. Whether that's in like room temperature or inside a freezer to thaw or in an oven to heat up a pizza or a lasagna I've seen. Just a good application problem.